Good afternoon, everyone, and thank you for being here. Welcome to our January 2026 installment of ENERCALC Office Hours. Want to wish everybody a very happy New Year's from the ENERCALC team. Hope everybody had a fantastic holiday season. We're excited to be back at it here. So, as you guys know, we have just a couple of quick housekeeping items to blast through before we get to our main program. So before we get going, I'm going to start with our typical sound check that we do. So if you direct your attention to the bottom menu of your Zoom window in your browser or your desktop app, you'll see the chat tool. Down there, we also have our reaction emoji and all the other Zoom tools. So if you're able to hear me just fine right now, give us a thumbs up, give us an okay in the chat, give us a reaction or an applause, your choice. Perfect. Thank you very much. Appreciate you guys confirming that. And then before we get on to our introductions and start the session, we also want to do a sound check and visual check for our primary speaker. So here in a moment, Mac is going to go ahead and share his screen. And once again, if you can hear Mac's voice here in a moment and see his screen, go ahead and give us a thumbs up, give us an okay, an applause, what have you. Go ahead, Mac.
Hello, everyone, and welcome to Office Hours and Happy New Year's.
All right, good deal. Now we have our tech checks out of the way. We are going to go ahead and disable the chat for today's session, and then we'll move on to some introductions. If you have questions, we have Q&A, which we'll discuss in a moment. So my name is Seth Roseworm. I'm a senior structural engineer and a software developer here at ENERCALC. And our presenter for our monthly office hours program is Mac Calterhoni. Mac is a senior structural engineer here at ENERCALC, and he splits his time between technical training for ENERCALC customers, working with the ENERCALC engineering team on the specs and technical behavior of the software, and then also helping maintain a presence for ENERCALC at national and regional events throughout the industry. A lot of you guys also know Mac professionally as the founder and managing principal of ELTA Design Group, which is a specialty structural engineering firm. He's been an ENERCALC user for around a decade, probably more than a decade now. And so he has a lot of great insight about the needs of our customers. If you're new here this month, Office Hours is all about direct line of communication between us and our users. And we do that through several avenues. We showcase new features. We tell you guys every month about updates and what's going on in the software. We dive into specific modules and we share optimized design workflows. And then every month you always have the opportunity to do open Q&A with the engineering team. If there's ever a question that's too involved or it's going to need deeper digging, that might be a better fit for our support team to investigate your concerns, look under the hood, and get you more detailed answers about problems you're having. As a minor point of order, you will notice everybody's microphones are muted just so we don't get any echo or feedback while Mac is presenting today. And as I mentioned, we do have open Q&A at the end of every session, including today. So to submit a question for today's session, just go down to the Q&A dialog in the lower dashboard of your Zoom window. If you experience audio problems at any point during the session, you should be able to just either refresh your browser if you're joined via browser, or if you're joined in the desktop app, simply close out and rejoin the session, as well as the native audio controls for Zoom. If you ever want to rewatch today's program or share it with someone else on your team who wasn't able to make it, all these recordings are posted to the Office Hours playlist on our YouTube channel, and you can also access those from the Office Hours page on enercalc.com. And with that, I'm going to go ahead and toss it over to Mac to get us going on our program for today.
All right. Thank you, Seth, for the introduction. And again, welcome everyone to another session of our monthly Office Hours program. This is the first session of 2026. As Seth said, I'm Mac Calterhoni, and I'm excited to be presenting to you today about the Steel Beam module from ENERCALC's library of diverse and extensive modules. So I'd like to start our session with a brief overview of the overall agenda. We have our monthly PDH announcement. We have ENERCALC's latest build, what's new in ENERCALC, Steel Beam module, of course, and then register for office hours to get notified, and finally live Q&A at the very end of the session. So I just want to briefly remind everybody that you will be by the end of the session, you'll be awarded half an hour PDH to the attendees that attended live, and this represents the guaranteed technical portion of the presentation. The name we use in the certificate is the same name that you used to enter the Zoom session today. So if you want your name to be displayed differently, then just exit out of the Zoom session and just get back in with the name that you want displayed on the certificate. And in a few days, you will receive a link, an email with a link to download your certificate. It's important to note that the link expires in 30 days. So the link to download your certificate expires in 30 days after we issue it. So please make sure you download your certificate promptly. And of course, if things happen and if you missed one of these links or you missed the window to download your certificate, please reach out to me or to us here, and we will send it to you. So first, I'd like to encourage everyone to check their software, make sure that you are on the latest build of ENERCALC. If you take a look at the very top of your software, you will see here the current build that you're on. ENERCALC releases monthly updates to the software, and we want to make sure that our users are taking advantage of all of the new features and the program capabilities that we've been releasing. And many times we receive support questions about issues that had already been fixed, but the user did not know that simply because they're still stuck on a build from 2023 or 2022. So a lot of times, a lot of the issues get reported to us and we fix them in these monthly updates. So always make sure that you're on the latest and greatest to get the latest and greatest. The current build of ENERCALC is 2026 0114. This actually was issued today, January 14th. So early in the morning, this became publicly available on our website. To make sure or to learn, to get a refresher on how to update ENERCALC, you just click on this update button right here in the upper ribbon. And once you click on that, this window will display where you'll have multiple options. We want you to check for updates and launch the For Our Users page, which is this one right here. And if you click on it, this will take you to our website. And if you scroll down just a little bit, you will find this second link right here. This is click to download Build 20 Updater. This expects to when you download it, you'll be able to run it, and it expects to see ENERCALC on your computer. If you don't have ENERCALC at all on your computer, then obviously you want the full installer. But if you're just updating, then this is the quicker updater that you need to download. And once you run through that, you're good to go. And again, if you want the program to automatically check for updates at program startup, you can just make sure that you check this option right here. So every time there is a new release, you will get a notification that program startup whenever you open it. It says, "Hey, there is a new update or a new build. Would you like to update ENERCALC?" A quick note here for users on build 2023 830 to 2024 0228. If your current build is anywhere between these two builds, is within this range, then unfortunately the feature to notify you of the availability of a new build, of a new update, does not function properly. So if you're affected, then you will have to do a manual update. You just have to do this one time from either the inside of ENERCALC or, of course, through our website. But that means you will have to manually go through the process that I just highlighted here by clicking on this and downloading the new update. So again, if you are not on that, then you're good to go. And the current build, again, is 2026 0114. And if you prefer to be notified of the latest ENERCALC updates by email, you can either scan the QR code or just go directly to enercalc.com/update-emails. And this will just collect your information here and consent to get email notifications. So now if you have not been on the latest build, or maybe you haven't had time to look around ENERCALC recently, we want to highlight some of the new features and functions that we hope that you can take advantage of. Some of these features are we released them even a few months ago, but we're still surprised to see a good portion of people attending office hours, or even a good portion of people that we see around conferences, that they still don't know about these things. So we want to just make sure that we get the point across and make sure that our users are taking advantage of the latest and greatest. So decoupling everything. This is just a recent thing that happened maybe about 3 or 4 months ago. And this is if you click on your building code right here, if you click on the building code and load combination button, you will now see a different window. The user now has the option to mix and match everything, codes and design standards. This means you can use an IBC edition that does not match the edition of the design standard. This is a great level of flexibility for our users so they can produce calculations that exactly match what they need. And in this example, you can see that we have IBC 2018 with ASCE 722 and NDS 2024. So obviously ASCE 722 is not referenced in IBC 2018, but certain jurisdictions recently have been mixing and matching where they are on an older IBC, but they want to leap forward and adopt a newer edition of a particular standard, such as ASC 722 or what have you. So this gives you that flexibility to mix and match whatever you would like to use based on the jurisdiction that you're working in. So all you need to do is to click on the sync reference design standards with the selected IBC button. If you want to bring everything back in compliance, or I guess in reference with the IBC 2018. This means if you already have this right here, a mix and match of codes, and now you just decided that you want to go back to whatever reference standards that the reference in the IBC 2018, you want to kind of go back to that, there's no reason for you to memorize or look up what the IBC 2018 references. All you have to do is just click on this button right here. And when you click on it, it brings back, it'll change all of these other ones right here back to whatever that particular IBC references. And you can notice here that this is shown highlighted in a different color, like a light orange yellowish color. This means that anything that is in this highlighted color, that means that it is not referenced in that design standard. That means that there's a mix and match going on. But if you click on this button to sync everything with the IBC that you're selecting, then you can see that everything will be shown in black, and this means that everything is indeed within what the IBC edition references. So keep in mind all of the code changes that we just talked about here will only apply to the calculations within this ENERCALC file. If you want to apply this code selection, this mix and match, or honestly even not mix and match, but just whatever code selection that you have, if you want to apply this as a default for all of your future projects, you will need to click on this button right here, which says Set Default Governing Code and Design Standards for all new project files. And when you click on this button, you will get this window right here, and it will show you what the old defaults were and what the new defaults that you want to implement look like. And it will also highlight the changes. So for example, I had the ASCE 722 here that's out of sync. Everything else is the same standard as referenced in the IBC 1218, for example. And now I just want to switch that from 722 to 716. So it says, hey, this is your old stuff. This is your new stuff. Is this what you want? And of course, you say save, and this will be now the default code selection for all of your future projects. The next thing that we have here, and we still get questions on, is the new ASCE 722 modules. So now we have new tabs that house the ASCE 722 loads and forces modules. We have a tab for seismic loads, wind loads, and of course we have a tab here for other loads. a user can create a calculation for whichever one of these that they want, and they can create as many as they want. Previously, before ASC 722, previously the user can only have one calculation per loads and forces module, but now you can have multiple. This is important to note that these new tabs will only show up, they will only appear to you only if you have selected ASCE 722 as the code. If you are on an ASCE 716 or older, then ENERCALC will revert back to the old option list of menu that everybody's familiar with. So these new tabs will only appear if you are, with all of these things, will only appear if you are on ASCE 722. If you're on ASCE 716 and older, it will default back to these, which is, that's what everybody's familiar with. So if you're on the new stuff, then all of this will go away from here and it will appear in these tabs. So if you are on a project, maybe you opened an old project or something, and you cannot locate your load and forces modules, then just always make sure that you are referencing the correct ASCE 7 edition, and you'll be able to find your calculations. So moving on here, we have native load linking within ENERCALC, and this has been such an exciting feature with a lot of development. For those who do not know, load linking is an ENERCALC native feature that gives the user the ability to automatically link reactions from one calculation to another, and the ability to change something in one member and have the effects of that change trickle down to all of the supporting members downstream. So load linking is currently available for steel beams, wood beams, steel columns, wood columns, and we have a new module that we just integrated that I will be talking about here in a second. But before I get into that, I just want to make sure that for anyone who would like to learn more about load linking, we created a playlist of short videos on YouTube to walk you through how to use load linking step by step, so you can start leveraging this tool in your daily workflow. We also added a new video to YouTube a few months ago, actually, that had to the YouTube load linking playlist. That has a full practical example of how to use load linking in real-life design application to transfer reactions from beams to columns. And this example actually covers, wood beams, wood columns, steel beams, steel columns, and the interchange of that. So, for example, going from a wood beam to a steel column, or going from a steel beam to a wood column, and so forth. So again, overall load linking is a powerful tool that allows the engineers to create a well-connected chain of calculations while minimizing the risk of transcription errors. Now, with today's new release, this is fresh, with the fresh release that we had today in the morning. This new build now has load linking that supports the general footing module. You can now link reactions from columns and apply them directly to whatever footing you're designing. This link will transfer axial loads, lateral loads in both directions, as well as moments in both directions seamlessly. So you never have to go through this manual process of transcribing reactions ever again. So that's just a quick overview of it. You can start seeing here that the general footing 1, footing 2, footing 3, and they have the symbol here for linked reactions, and you can see here you get this new tab that says linked loads, and you can grab from various columns. You actually get a lot of good sketches here. You get a base reaction, you get a plan sketch, you get an elevation sketch of each one of these already incorporated, and then finally you can import whatever or link the loads that you want, and you can see here if I'm linking load from column 2, for example, you can see here that we're receiving axial load, we're receiving shear in the x direction, shear in the y direction, and of course we're receiving moment in both x and y directions and all of that. So this is a great development, and especially next month we'll be able to talk about this a little bit more. But if you have not already updated to the latest and greatest build, this is your time, because now you can take a full path, a full load path in the gravity direction. You can take it from um, uh, you can apply the loads from a beam to a girder to a column and to a foundation. Everything is very well connected here for you, and you don't have to carry anything, carry any of the reactions by hand anymore. Moving on here, which is our next item, which is export results to CSV, and this is the ability to export tabular detailed results from ENERCALC to a CSV file. This is useful to many engineers who want to post-process some of the results outside of ENERCALC. All you need to do is go to the results that you're interested in. So, for example, I want the ASD shears and moments. All I have to do is just get anywhere here, right click, and then from this menu, I get to select whatever I want. So for example, I want to save to CSV here, and it will download to your computer, and you can post-process that data however you see fit. You can pretty much export results to CSV in all of our modules, including columns, beams, slender walls, shear walls, foundations, and the analysis module. So you have plenty of flexibility there. And by popular demand, we made an important update, and that was also a few months ago, but a lot of people are still getting surprised when they see it or when we talk to them about it, which is the general footing module now supports reinforcement or top reinforcement. So our users now have the option to specify top reinforcement in the footing for those cases where the footing experiences tension at the top rather than the typical case, of course, of having tension at the bottom. You can specify the rebar size and quantity separately for each direction. And you can see here on this table right here, for example, this is the results, the results tab, and you can see it shows you a lot more information to help you navigate the results, like saying, hey, top tension, and all of this information, so you can navigate a little bit here with your rebar sizes and quantities in case you need to increase or decrease that. So pretty much now in these footings, you can apply top layer, top reinforcement and bottom reinforcement, and then you can apply it in each direction. So for the top layer, you can apply it in the X and the Z direction, and then the same thing for the bottom layer in the X and the Z directions. Our next update is the ACI 318.25. So we recently added full support, full incorporation of the ACI 318.25 in our modules. A few jurisdictions, starting with actually Georgia, is set to adopt the ACI 318.25 this month, like in January, actually. And we're seeing this happen more often now more than ever, where a jurisdiction adopts a certain IBC edition and then leap forward and grabs a more newer edition of a certain design standard. So, and that's exactly what's happening in Georgia. That's what's been happening with certain jurisdictions with the ASCE 7, where they forward adopt that standard specifically. So, and in Georgia, what's happening, it looks like they're adopting the ACI 318.25 ahead of the IBC cycle. So again, now this is fully incorporated, and you can see here from that list that we're looking at earlier, if you click on the building code and load combinations, you can now hand pick the ACI 318 edition that you want to use for your project. Implementing ACI 318.25 in ENERCALC allows, again, our users to have that great level of flexibility they need to keep their drawings and calculations compliant with the authority having jurisdictions over their projects. And then here, the last update we have is the subscribe to release notes. And this is actually pretty useful. I personally use it to just kind of see what everybody what's new in the new edition that got released or the new build that gets released. So with every new update to ENERCALC, we send out release notes to outline what changed and what got updated and what got fixed. This gives you a quick idea about the top changes, so you can take advantage of those new features and know that, okay, well, certain bugs got updated and all of that. So this is a good thing that we do once a month whenever we release an update. And you can subscribe to receiving these release notes simply by clicking on, again, the update button here, and then you click subscribe to the new build email updates, and you'll be good to go. So with that being said, we are ready to dive deeper into the meat of the presentation today. So the focus of the presentation today, and that is the steel beam module. We use this module to design steel beams, steel outriggers, girders. It's a very popular module that most of us use almost on a daily basis. Here's a quick overview of the capabilities, and this is definitely not an inclusive or exhaustive list, but just an overview. It can perform, or the module performs full design checks based on the selected AISC edition to determine the section capacity. You can apply various load types, uniformly distributed loads, concentrated load, trapezoidal loads. ENERCALC can also design beams loaded in the minor axis. That's YY bending. That's flatwise weak axis. Designs using, of course, ASD and LRFD methods, and it has also a beam size auto select feature that comes in very handy, and we'll talk about it today. You can link reactions from different calculations for easy and accurate load application, and of course, a summary PDF report for your calculation package. So the objective of today's session is to walk you through how to use the steel beam module to design a steel girder that supports floor loads from a slab on one side, and on the other side, it supports a series of steel beams. So we're using IBC 2024. The max span of this girder is 30 feet. Dead load is 80 PSF, and live load is 100 PSF. It supports a floor slab on one side. The trip width is 5 feet, and it supports W12 by 14 steel beams, series of steel beams on the other side, and those beams are spaced at 6 feet on center. And to give you a little bit more idea, this is a sketch of what this looks like. So we have a couple columns here. This is the girder in question. This is what we're designing, and it's 30 feet. The max span here is 30 feet, and the nearest beam is 10 feet away, and you have your deck right here. And this is, so that's where the trip width here is 5 feet. And then from this side, we have a change of direction as far as the deck is concerned, and we have new, smaller beams here, W12 by 14, a series of them. The first one starts at 3 feet from the left, and the rest of them are balanced at 6 feet. So now that you have an idea of what we're trying to do, or what we're trying to design, so let's get to it. So we follow the same familiar process that we always do. We start by clicking on the Add button, of course, and then we click on the beam tab here, and then we select steel beam to start a steel beam calculation. Typically, we work our way from left to right throughout all these tabs until we're done with all of the input tabs. So starting with the general tab, we'll give our calculation a name. I'm going to call it a steel girder. I always suggest people who are working on active projects is to give it actually a much more meaningful name. Not just steel girder, because the building is going to have a bunch of them. So always try to have some sort of a system so you can so you can name your calculations a lot easier for other people. But anyway, so we're just going to call this steel girder. I personally do most of my design. I do it in ASD, so that's what I'm going to be using. But ENERCALC supports LRFD design method. So if that's your preferred design method, you can just click LRFD here. Next, we need to input some material design values. We will be designing a wide flange girder, so we will use FY 50 KSI. And of course, modulus of elasticity of steel for steel is 29,000 KSI. If you are not sure what to use for FY, and if you don't have your steel manual handy to look at your material and all that stuff, you can click on this button right here, and this window will appear. And this will help you look up different ASTM steel designations and steel section shapes. So, those are your W, your M, your S shapes, all that. And this is your HSSs, your round HSSs, your pipes. So you can click on that, and then you'll see here a few materials, A36 or A529 or whatever. And then each of these ASTM steel designation has the various FY that's being made in. So this helps you a little bit to figure out, or a quick lookup to help you move forward. But either way, we're just using 50 KSI, which is very common. Now we need to define the compression edge lateral bracing condition. Many people call it the compression flange, but the more general term is just compression edge. So we're trying to define that lateral bracing condition. ENERCALC provides multiple options. You can, of course, select the compression edge to be fully braced. And if you have a multi-span beam, you can actually define bracing conditions separately for each span in case each span has different bracing condition. So this is the first couple options here. The third option, very easy, completely unbraced. Then we have this last option right here, which is set uniform spacing. So that's whenever you have maybe a joist that sits on top of a girder, and you want to consider those points where the joist is in, or the joist is sitting on top of this girder. You want to consider those points as bracing points. So then now you have to provide this spacing. So the girder, an example, is receiving, it has a deck on top of it, at least from one side for sure, and that's most of the time is enough consideration for compression side bracing to be considered completely braced. Some people might, alternatively, you can say, especially maybe if there's a different weird condition that you have, clicking on compression side fully braced is easy. You just click on it and you move on. But for the purpose of this example, I just want to walk you through how to set the uniform spacing for the lateral bracing. This is what I want to do here. So this is just for illustration purposes. So with that being said, assuming that we are braced only at those beam locations, we're not going to consider the deck at all. We're just considering that these beams are the ones that are bracing the girder. So what it asks you for here, it says, okay, well, set uniform spacing. The first thing it wants, where is the first brace is located? So we're going to say the first brace starts at 3 feet from the left. And then regular spacing of lateral supports, we want to say it's at 8 feet on center. The last question is use inflection points as bracing points, and you have this option. I will not be checking that. I will not be using an inflection point as a brace point, but if that is something you want to do, ENERCALC allows the user the flexibility to do that as they please. So this would be the bracing condition that I'm setting up here for this girder. Then we're ready to move on to this last item that we have, which is CB always 1. Do you want to implement this or not? So you have this option again. If, for example, I'm going to go ahead and check it because I normally don't check it for all of our previous office hours. sessions. So I'm just going to go ahead and check it this time just to show you what it looks like if it's checked. And this means that ENERCALC will just straight up use 1, which is conservative, obviously, but it'll just use 1.0 for all your calculations. Alternatively, if this is not checked, then what happens is that ENERCALC will actually perform the calculation, based on your how the moment is distributed, and once it'll calculate a CB and it'll implement it to help you kind of get you a little bit of extra capacity there as much as it can, or as much as it's allowed. So moving on to the next step, which is the beam span data tab. Based on our sketch, you can see here that the span length is 30 feet right here. So we just input that information. That's pretty simple. And this one here, this is a cool option, which is we have the option to, we have the option regarding the beam orientation. So if this option is unchecked, then the beam is being loaded in its strong axis. That's normal, which is this orientation that you're seeing right here, and the load is on top of it. However, if you check this option, the beam will be loaded in the weak axis, which creates, of course, YY bending. And this is the rotation right here. It's 90-degree rotation. So furthermore, if this option, again, is checked, the sketch on this right-hand side, the sketch that you're seeing right here, will actually graphically update to show the proper beam orientation. And hopefully this is a good visual reference for everyone working on this to say, hey, this is happening. And it also changes the 3D representation graphically of this beam. So again, it shows it sideways, in its weak direction, rotated. And again, just for proper visual depiction. So this way, as you're working, whatever you're doing in the input tab, it's actually being represented properly in the 2D and the 3D sketches to help tie everything together. So, however, we will not be obviously checking this option since our girder is loaded in its primary strong axis. So, but it's just good to know that this option exists. So next we pick the beam section that we want to check. So if you want a square HSS or HSS rectangle or pipe or whatever you're trying to use here, for us, we're just using a white flange beam. So we pick W here, and whatever you pick from here, this table will auto-populate with all of the AISC section sizes that we're accustomed to. And you can actually click on this button that says Select Edition. You can actually go and get a different older edition for the sizes, not necessarily for the design checks. The design checks are performed based on the loading combination based on the design standard that you set in the for the whole ENERCALC file, as we talked about it at the beginning of our session today. So that one is for the design and everything. This one right here is just for those sections. If you are looking maybe for an older AISC, maybe from the 14th edition, or maybe a historic section or something like that, you can grab it from there. So again, for us, we're just going to continue using the AISC 16th edition. And for this example, I'm using a W21 by 57. Now, if you're not sure what you want to use, you can utilize the auto select feature to help you decide and evaluate various sections based on a predetermined design criteria. It's predetermined by you, but it's a design criteria that you tell ENERCALC. So if you click on this option right here, on this button right here, you will automatically get this window. It tells you, okay, well, what section do you want ENERCALC to look at? We want it to look at, W sections. Then you get this right here. What is your maximum stress ratio? Do you want to drive this all the way to 1? Do you want it 0.8? Are you like 80%, 70%, whatever? For me, I'm just for this example, we're using 0.9. That's the max stress ratio that I'm comfortable designing to, for example. So I'm just going to use 0.9. And then you see right here, you can set different deflection ratios. So for total load, 240, and for transient load, live load, is 360. So that's pretty common, so we're keeping that. And then you have these two options, something called depth class and something called depth limits. Depth class is is the generic term that we're using for if it's a if it's a W14, then a depth class of 14. If it's a W18, it's a depth class of 18, and so forth. It's not really a dimension. You're just it's not a strict dimension. It's just the class. The HSS 8, then it's 8 and so forth. So for us here, I'm going to go between 8 and 24. Depth limits. This is actual exact member depth. So this is a little bit different because the depth limits is your actual depth, not the class. So for example, some W14s are slightly taller than 14 inches, maybe 14.1, 14.2, whatever. So if you have a serious restriction on member depth, you can input that here. This will ensure that the actual depth of the member does not deviate from the depth limits that you are using. So if you say you can choose any W14 here, for example, you say W14 here, and then you turn around and you say 14 inches, this means that the W14 members that exceed 14 inches, maybe they're 14.1 or 14.2, they will be excluded from this auto select and evaluation feature. So this is a good thing here, especially if you have very specific and restrictive requirements that restrict your depth. So anyways, once you're done with identifying all of this, you click on Start Design, and you will get this this window. And this has all the results for you to evaluate. So I'm sorting everything by weight, but you can sort it by, bending ratio, total deflection, depth, even whatever you really want to sort it by. But we're just going to go by the weight for this example. And based on this, I could have used a W24 by 55. It still meets the bending ratio is fine. All of this is fine. And the same thing for a W21 by 55. So doing this kind of helps open your eyes just slightly to see what's going on. And again, but for our example, I'm going to continue using the W21 by 57. The last item under this tab is setting the deflection limits. So all the way down here, you can see the maximum or the minimum allowable deflection ratios. So again, for transient load, I'm still sticking to L over 360 and total load L over 240, which is pretty typical, but you can do whatever works for your specific project. Next, we move on to the span loads tab. Under this tab, I want to apply the load on the girder. I want to start with, we're going to start with this side right here where we have the slab or the deck. So this deck exerts a uniformly distributed load on the girder. So we'll just click on this right here. So you go, you add a load, you click on uniformly distributed. I always encourage everyone to have a little description of the load source, so you know just where the load is coming from. So I'm going to call it here typical area load, one side, and we have 80 psf, and we have here 100 psf for floor live. And then we want to check this option, use trip width. So I want to say, I want to enable this. So now we can say the trip width is 5 feet. This is where you input it right here. And again, the 5 feet come from right there. So now that we already added this load, and this is good to go. Next, what we need to do is apply the we have the other load right here, which is the load from those beams. Now we can apply those loads manually in two different ways. The first way of doing it is to say, okay, well, I'm going to add a point load and figure out what my reaction here is. Say a point load, and then put it, and then it asks you where to put it along the length of the girder. We say 3 feet. And then we create another load, another point load. We put the reaction and we say, okay, well, you're at 9 feet, 6 and 3. And then the next one, you're at 15 feet, and so forth. That's pretty labor intensive. Many engineers opt for idealizing this a little bit as a uniformly distributed load. So they will just do the same thing that we did right here for this deck, and they will just apply uniformly distributed load and take a tributary width right here and apply it that way. Both of those ways, of course, are manual, and you can do them based on your project or based on what you're comfortable with. But what I recommend is that we do this the smart way by using and utilizing the easy way by using and utilizing the dynamic load linking feature. So before I started designing this girder, I had already designed the W12 steel beams. This is the logical flow of design and of load path. So I already designed, the primary beam just so I know what's going on. And then I called it here in my calculation. You can see this snippet here from that calculation. We're calling it primary beam. So we already designed this, and now we're in this steel girder and we're trying to design this steel girder, and then now we click on the linked loads. So now that you have this primary beam designed, you should take advantage of that by linking the reaction from the already designed beam directly into this girder calculation. This way, if the primary beam reactions ever change, I will never have to go and manually track down what that change is and change it manually in the girder or whatever member I have downstream. The loads are linked and will update automatically like a well-connected chain. So if anything changes in this one, it'll automatically be updated, and I don't have to manually track it. So to implement this, we click on our next tab here, which is the linked load tab. On the left-hand side, you will find the other calculations that you created in this ENERCALC file. Now, for me, I only created the primary beam calculation, so it is the only calculation that's displayed here. But if I had created, let's say, I don't know, 5, 6, 7 other beams, they will all be displayed right here for me to choose from. So they will all be here. So once you click on this beam, whatever you want to select, once you click on it, this 2D sketch right here will update dynamically to actually show you what that beam that you clicked on really is. So for this case, you can see that this beam, when we clicked on it, you can see here it's a W12 by 14. It shows you what the beam looks like. It's simply supported, and it labels the support points. This is support point 1, this is support point 2, and it shows you even what that load that's applied on it. Then below that, you get to see here the reaction table. And you see here support 1, and this is support 2, and you're seeing all of the reactions from support 1 and from support 2. So what I want to do is I want to grab the reaction from support 1. This is the one that I want to apply on the girder. So I'm assuming this is support 1 and support 2 is somewhere here, not shown. So I'm grabbing that reaction from support 1 and I want to implement it on the girder. So I click on it. Once I click on it, it says, okay, well, how do you want to apply that load? And you have various ways of applying this load. So you can obviously do it as maybe at a specific point, maybe at just 5 feet from the left, and that's it, or maybe apply it at mid-span, quarter points. But what we really want to do, we want to apply this load at a specific spacing because it's a repetitive load. So what I would do here, we click on the spacing option right here, and I'll ask you, okay, well, where does it start? Just similar to what we did with the bracing, the similar logic. So it asks you, where did it start? We say, okay, we want it to start at 3 feet, obviously from the left. So that's the first part. And then the rest of it will be spaced at 6 feet on center. Once you do this, and then you click on this button right here that says link load, then that load will be displayed right here. And this is here, this is the linked reactions table. And once that load is displayed right here, that means that this has already been linked and you're good to go. Once that load is linked, you can clearly see it. And the bottom table houses some useful information, like, for example, we're grabbing a reaction from beam one or primary beam, we're grabbing it from support one, for example, and all this stuff. And it gives you the idea, okay, well, this is 3.6 kips dead and all of that. So this is a quick review for you for your reference. Now that all the loads have been applied, I always like to go and just check under the 2D tab to make sure that everything is linked correctly. You can see here that the linked reactions from the primary beam, they're shown right here. And, again, 3 feet, 6 feet, and so forth. And they're shown in blue, so that's a different color because they're linked. This load right here is the manually applied, uniformly distributed load, and that load is shown in black. So you can see everything here looks great. Then you're like, okay, that sounds good. This makes sense. This is exactly what I was expecting. So lastly, of course, you go to the load combinations. This is a very common tab that we have pretty much in most of our modules. You can select whatever combination you want to run. You can have your own combinations. For me, I'm just using the standard ASC 722 combinations. And of course, ENERCALC allows you to control the strength combinations by themselves, the reaction combinations by themselves, and of course, the deflection combinations by themselves. So this way you can implement your combinations however you want them to be implemented. Now that we're done with all of the input tabs, we're ready to evaluate the results. Going under the calculations tab, summary results, you can see here the maximum ratios. That's bending stress ratio of 0.849 and maximum shear stress ratio of 0.197. And, of course, the design says, okay, so this beam is good to go, your W21 by 57. If you need more information, you can go down here a little bit and you can find what your applied moment is, what your allowable moment is, and what load combination that controls that. And the same thing right here for the for shear, for example, and you can even get the location of shear. Of maximum shear. Next is the deflection ratios, the transient load deflection. You will get that as an absolute value, which is in this case 0.68 inches, and of course you get it as defined as a ratio, which is right now this meets L over 528. 528 is larger or equal to or larger than 360, so you're good to go. Same thing here for total deflection. And of course, the last piece of this page is the extreme reaction. So for support one, your extreme reaction dead is 15, and your floor live load is 18.75. Another useful tab is the max combinations tab. You get to see here a bunch of combinations. You get to choose which one you want, and you'll get to see a lot of intermediate values. In this case, you can see here the CB, for example, is forced to be 1, but this could be if the option for CB, if it wasn't forced to use 1, then it would have actually calculated what that number is. And then, of course, you get to see here your capacity, your applied moment, and all of that, and a bunch of other intermediate values that might be useful for you. And then under the diagram tab, of course, you will find the shear diagram, the moment diagram, and deflection diagram for those visual engineers who like to make sure everything looks orderly. And then this wraps up your overall design of that girder pretty much. So overall, the steel beam module is a very useful and popular module among our users. Coupling this module with load linking capabilities, you get a robust workflow that changes dynamically as you make future changes and revisions and all that. Especially now that you can see this where you got the load from the beam to the girder, and you can grab that reaction from the girder to the column. And with today's release of general footing incorporation into load linking, you can finally take that load from the column to the general footing, and you did not have to write any reaction down or do anything manually. So one more thing that's worth noting here is that our library of verification calculations is growing. You can go to our website for our users, and then you click documentation and then verification calculations. So you can see it right here, documentation and then verification calculations. You will see latest and greatest list of verification examples, and we will be adding more there as we produce them. Also here, this is the verification example that we made for the steel beam calculations. This is already available on our website. This will help our users check out the design, or, check out the design checks that ENERCALC performs, as well as compare those hand calculations side by side with the ENERCALC printed report. This way, it helps clear some of the inner workings of ENERCALC, and this actually can serve as a great learning resource for younger engineers, or even a quick refresher for those who need it. Or if somebody is using ENERCALC for the first time, this will help you verify results without having to invest too much time of your own time trying to figure this out. And as always, of course, you can go to enercalc.com/office hours to register for office hours and to access all of our previous recorded sessions right here. Every recorded sessions, office hour sessions get uploaded pretty much a couple days after the session goes live, or the session is over. So you'll find them there and you can watch them at your leisure. We've got we attended plenty of events, plenty of conferences last year, and we're grateful to our users. We got to connect with them in person, and we're looking forward to 2026 as we have full schedule, and we're starting with the Structural Engineers Association of Utah's annual conference in February 25th. Chelsea from our office will be representing ENERCALC, and will be there to answer all of your questions and then some. And if you're attending the Utah conference, please be sure to stop by and say hi to her and sign up for the cool Lego raffle she's having. So if you're in Utah, you should check it out. And this is the end of our session today, and we're ready for any Q&A.
All right. Thanks, Mac. Let's get into some questions. So first question, will the CBC, that is the California Building Code, be added to the code reference in the future? Current latest version only has IBC and ASCE. So this is a frequently asked question, so frequently, in fact, that there's actually an FAQ style page about this on our website. So ENERCALC now only includes IBC and ASCE as its primary code references. So at this time, we don't have any plans to specifically branch out into local adoptions or local amendments like the CBC, Florida Building Code, Connecticut Building Code, and so on. There's several reasons for that. One of the main reasons is that we now have the a la carte design standard selections, which Mac went over, where you can make your own collection of different ASCE, AISC, ACI code selections. So you have that capability. You also have the ability, if you need a calculation report to say California Building Code, or I'm the engineer of record, I say this meets California Building Code, we have what Mac is showing you on screen right now, which is the state-specific note feature where you can go create a note of whatever you need to say to the attention of a plan reviewer, authority having jurisdiction, what have you, and decorate all of your calculation reports with that note. So you can say, hey, this has been checked by the engineer of record in accordance with CBC 2022, 2024, what have you. So there's several different features we have specifically to support our users who work in different jurisdictions with different approaches to adoption. So if you're interested in learning a little bit more about that, I'm going to copy that link and actually drop it in the chat right now, just so you guys have that for reference. Feel free to check that out. And then obviously reach out to the support team if you have questions about how to implement those state-specific note features, the a la carte design standard selections, and so on. And feel free to ask a follow-up if you have more questions about that. Next question.
I just want to add one thing to this.
Yeah, go ahead.
Is that's what it looks like. So when you go right here and you say include a note and you write whatever you want to write, and you say save as custom note, what happens that this is what it's actually going to look like. So if you have a note right here, whenever you print your calculation, this note will be displayed right here. So it looks pretty professional. It shows that you have done the whatever work you need to do, and that's what it looks like. I just wanted to know what it looks like with that note printed on the report.
Yeah, on top of the fact that you now have the ability to tune your material specific design standards to suit whatever jurisdiction you're working in, which gives you a lot of
Exactly.
flexibility. Perfect.
Exactly.
All right, next question relates to the release of ACI 318.25. Please verify all the reinforcing bar anchorage requirements are included in the ACI 318.25 modules. There have been many changes. Yeah, there definitely have been a lot of changes. And so just to be clear on our terminology, the reference was to reinforcing bar anchorage. I'm going to assume that that's a reference to bar development length. As most of you are probably aware, ENERCALC does not address Chapter 17 anchorage to concrete, but we do bar development lengths. So all our modules, which include rebar, straight bar, hook bar development lengths, have been updated. So your rebar development is updated, your cantilever retaining wall, restrained retaining wall, tapered retaining wall, as well as all the shear provisions. Those modules I just listed, that specifically has to do with bar detailing provisions in 318.25. But obviously, we also have gone through our concrete beam module, our all of our footing modules where shear capacity is checked, so on and so forth. And we're definitely diving into that, and it's all updated and compliant. And I did see a hand raised. Please feel free to go ahead and to ask a follow-up question if we didn't fully answer your question on the California Building Code. Go ahead and drop that in the Q&A, and we'll get to it here in a minute. Question from Ronald. Please explain support 1 and support 2 for a beam. Mac, can you go back to your example if you have that pulled up? We just want to clarify what's meant by support 1 and support 2 in a load linking context. So,
Yes.
Ronald, hopefully we can cover your question here, but the way every ENERCALC module works, your supports are always numbered from left to right. So even in the case of a left-hand cantilever, the free end would be designated node 1 or support 1, and it wouldn't have any reaction force. Then you'd have 2, then 3. So you're always going to see those numbers start from left and number from left to right.
And I want to add to this that, so if you have a beam right here and your loading is different, so for example, right now the loading is exactly the same on each end, but if you have a beam that has that loaded differently, that's why, in my opinion, this sketch is really useful because you get to see what the sketch looks like. It specifically labels the support you're looking at. This is support 1 or this is support 2 or this is support 5 or whatever it is, and you get to pick whichever you see on the sketch. You say if you want this one, then that one is 2. If you want this one, then that one is support 1. I hope this makes sense. But that's the best thing about this is that you always should check this 2D sketch and see which end is labeled what. So this way you can grab the proper reaction that corresponds to that support that you're looking at.
Perfect. Okay. And I see a follow-up question from Ronald Mack. He's making reference to the floor plan. So just to be clear, the floor plan that Mac is showing there is not a feature of ENERCALC. That's just a plan that he generated on his own. That's
Yeah,
a
this is an
Bluebeam
example.
sketch that's just sort of a visual aid to go with his calculation. So in that context, he could orient it however he wants to. There's not a programmatic correlation between the sketch you guys see there and what he's doing in his calculation. Hopefully that makes
Yeah,
sense.
yeah, this sketch is just an example because this way, so this way you can relate to it when you're designing this. This is just a floor plan and sketch, not to scale. And it doesn't even show the other end of the beam. So, but if we have this beam right here, the W12 by 14, sits on a girder here and it sits on another girder somewhere else, then one end is labeled support 1 and one end is going to have to be labeled support 2. So I hope this makes sense. But yeah, this is a Bluebeam sketch.
Perfect. Okay, next question. can the steel beam module be updated to include calculation for camber? So I want to say that we've answered questions about camber in the past. Um, there is certain information available in the steel beam module that you can use to address camber type design concerns because the deflection results, as Matt can show you if he still has that calculation pulled up, the design results do give you granular outputs by different cases and combinations. So you can see, for example, the dead load only deflection. You can use that to help inform your design decisions. There's not explicitly any features built in the ENERCALC module that include design for camber per se. So if you're wanting to see additional features on that, absolutely go ahead and reach out to the support team, support@enercalc.com with the details of that feature request. If there's something you'd like to see different, um, that's explicitly helping assist you with your camber design process. But as Mac is showing you here, go ahead, Mac, you can see some detailed deflection results that relate to dead only
Yeah,
effects.
you get full granular results in terms of deflection. So you go this from MVD summary, and then you go to deflections tab, and then you click on which one you're interested in. So for example, just dead only, and you open this, and now you'll see it along the length of the beam. So our beam is 30 feet. You can see the incremental deflection um, as a number and as a ratio, whatever you want there, and as it go through it. So by the time you get to the middle of it or whatever you're expecting to see that maximum deflection, you can go through. You get all of this information. So this should be all the information you need to kind of take it a little bit a step further there
Yeah,
and
and if you just
get
want
your
to see a
camper.
visual presentation of that, you can also go to your diagram tab where you can also, as hopefully you guys know, you can filter by individual combinations. If you uncheck that display all, then you'll see one combination. And this is one of the deep cuts that we like to draw attention to is the slider capability. Not everybody knows that if you go to a single combination or case display, you also have that slider to get a specific visual depiction at a certain location. So that's just a handy alternate way of seeing your results other than the tabular view that Mac just showed you guys a minute ago. So hopefully that helps. But again, if you do have more detailed feature request, absolutely fire that over to us. Don't hesitate on that. Next question. Can I design? Oh, this is a good one. You'll like this one, Mac. In fact, we answered a question similar to this last month, I believe, related to wood beams. Can I design multi-span with different beam sections in one design? ENERCALC always assigns the same section for all spans. So the one word answer is yes, you absolutely can. You have the capability to um and I'm forgetting
What?
exactly where the
Yeah, I know for wood beams we can. Let me check here for steel. Because yeah, I keep on forgetting. I know which one of them you can and one of them you can't. Give me 1 second. Beam size property. Because I
it's all
will
the way over
definitely.
directly above the 2D sketch. Use for current span versus use for all spans next to your auto select button.
There you
There you go.
go.
Yeah, you have to have multiple spans to have that option show up.
Yes,
That's why
that's
you and
the
I
one.
were both
And
we're both
yeah,
frozen up there. So
and
the answer is yes. As soon as you add additional spans where you have more than one span on your beam, you're going to see those options appear right where Mac was just pointing there. And you'll have the option to toggle that section size on your beam span data tab from use for all spans, use for current span. You can jump back and forth, and that way you actually can designate a different section size span by span.
it's the same thing for the wood beam. I know last time again I froze, but for the wood beam, once you add another one, you get this additional option that says, okay, yes, you can separate them by span or use them for all span.
Correct. All right. Next question. Will any modules on aluminum elements be developed in the future? I think I can say pretty confidently we don't have any active plans or active projects right now to implement aluminum design. But again, we definitely track those things. And if that's something that's important to your team, absolutely fire that over to us. That's how those things climb the leaderboard. So don't hesitate, send those over. The whole engineering team sees them. Mark, our CEO, sees them. The development team sees them, and that's how we decide what customers need is by what you guys tell us. So don't hold back on those. And I do still see a couple hands raised. If you guys have questions that we haven't managed to cover, feel free to drop follow-up questions. Next question, can ENERCALC check the rooftop concrete slab? So I'll answer this question in a couple of ways here. If you're talking about a steel composite slab on deck where you have concrete slab over a VLI or VLR deck, something like that, or even a form deck, ENERCALC does not have modules that are explicitly designed to do basically SDI, Steel Deck Institute approach to composite slab design. So you're not going to find anything like that. A lot of engineers just use the Volcraft span tables and stuff for their composite slabs. But if you're talking about concrete slab, we do have an entire FAQ talking about um, things to watch out for so that you can use the ENERCALC concrete beam module as a design aid for a slab. Obviously, there's some differences in detailing, reinforcement, and so on, but we do have an FAQ about that. Mac, do you have thoughts on that?
No, that what you said just covers it, right? Yeah, we don't have anything for it.
Yeah, but if you're talking about a solid concrete slab, then you do have
Then
some
yes.
flexibility there. Next question. Is it possible to make a hole after creating circular shells? That sounds like an ENERCALC 3D question. I know that in ENERCALC 3D, you do have a lot of flexibility for robust modeling, if that's what you're referring to. Um, Definitely feel free to send us an email to the support team, support@enercalc.com, if you want to get more into detail. We have a lot of great documentation about modeling in ENERCALC 3D with plates and shells and membrane elements and stuff. So if you want to dive deeper on that, feel free to send that over to us. Next question. Question regarding concrete beam design, specifically regarding the D values in design shear. Send an email on Monday 1/12. Okay, so if there's an email out to the support team, rest assured the engineering team is looking at that. We definitely know that there are some engineering challenges associated with the effective depth D and how that plays into the shear capacity of a section. We have been implementing some new features to give more flexibility on that front. So those limitations you may be bumping up against or may have bumped up against in the past are not going to stay forever. The engineering team's working hard on expanding those capabilities. But yeah, feel free to follow up on that question. But I'm sure the engineering team is actively looking at it right
Yeah,
now.
I want to confirm, Seth. Yeah, I see. Yeah, we'll receive this question. We're looking into it, but we at least I want to confirm to him that that we have it.
Yeah, and that's something that Derek and several of our senior developers have been working on in the concrete beam module to expand the flexibility of defining, which bars are participating in behavior for positive versus negative moments so that we're not inappropriately skewing the centroid of reinforcement, which then skews the effective depth for shear capacity and so on. So it's definitely something that's on our radar and is seeing a lot of effort from the team. Hopefully that helps. Next question. Will we be able to analyze axial tension in members in the column module? So I'm not aware of most of our modules allowing net tension right now. I haven't tested that in a minute. I know for a fact in the concrete column module, we do stop you short if you have net tension in a column. I haven't tested that in a minute on the steel column module, but I believe that most of our column modules are not set up for net tension. They're primarily designed for compression. Um, Go ahead, Mac, if you have something about that.
No, I think that's right. I was gonna just check it out here, but yeah, I think that's the same thing even for footings. Just net tension is not supported.
Yeah, and again, if that's something that needs to be a feature request where you say, hey, we have a use case where we see this all the time, we'd like to see this. Definitely reach out. I can't tell you for sure it does or doesn't on the steel off the top of my head. I would have to test it, but I know for sure the concrete column stops you short. Question from Jesse Burke. Shout out to South Carolina. South Carolina's in the
Uh-huh.
in the building. All right. Good question, Jesse. So, a lot of engineers do use the beam analysis module to just do
I don't
plane
think he read the
analysis.
question, Seth.
What's that?
I don't think you read the question.
Sorry, any plans to add a module for steel bar joist design? So a lot of engineers do use the general beam analysis module to assist with bar joist design. In the future, most likely, we'll be trying to add load linking integration from the beam analysis module to our other beam modules, column modules. So that'll add a lot of flexibility. Um, but if you're doing a joist where you need actual product selection, we don't have that capability right now. But again, if that's something that's useful to you guys, you'll feel free to send that as a feature request. Next question. Any plan to use a deep beam or concrete soldier pile system? Good question. So, concrete deep beam is definitely sort of its own can of worms because it's different than your conventional flexural behavior that we do in the reinforced concrete beam module. Um, I don't think we have anything actively going on that, but you can always reach out if you have specific specs or specific tasks you're trying to accomplish. A lot of times, deep beam turns into strut and tie analysis for some engineers. That's where they'll go, and that's certainly not something that's trivial to package in a module environment um, because there's so many assumptions and judgment that goes into strut and tie analysis. But if that's something you're interested in for deep beam, definitely send that over to us in the form of a feature request. And then concrete soldier pile system. I'm not aware of a specific module or development effort that's in the works right now. But again, that would make a good feature request if there's a use case you guys have. You said concrete soldier pile, so I'm assuming the existing soldier pile earth retention capabilities we have don't meet your needs. But if you haven't looked at the existing soldier pile wall module, um, definitely feel free to check that out and see if that might be a valid capability for you. And this is kind of a repeat question. Bar joist design module will be included in ENERCALC in the future. Like I said, right now, if you're doing a KCS joist where you need things like maximum shear, maximum moment, deflection with a certain moment of inertia, and reaction forces, you can do all of that with the general beam analysis module. We don't have anything right now that lets you make the leap beyond that into actually picking manufactured products. However, um, you know, feel free to send that to us if that's something that you guys want to see. Mac, this next question's right up your alley. Any plans to add cold form steel design modules? We hear
We've
you.
been aware of the needs. Definitely we hear you. It's this is definitely not going to be it's a known limitation. It's not going to be a limitation forever.
Yes.
That's for sure.
For those of you who don't know, Mac, what does Elta Design do?
That's all we do. Just conform steel design. That's what I
All
do day
Mac
in day out.
does,
So.
his entire company is all about specialty engineering, cold form steel design. And so we've been aware of this limitation uh, long before office hours sessions began because all of the engineers who make up the ENERCALC structural engineering team all worked in engineering practice for years and years as licensed engineers. And so we all joined the ENERCALC team knowing about these limitations and bringing our own thoughts about what we want to see done in the future. So cold form steel design has absolutely been on our radar for a long time. It's something that we're diligently studying and without making grandiose promises, I can say confidently don't expect that to just remain a void and a complete lack of capability forever because it's definitely on our radar and it's something we pay attention to. Cool. Well, that was a lot of great questions. Thank you, everybody, for sticking with us past the hour here. 20 minutes past, actually. Mac, do you want to kind of wrap us up with a teaser for next month and
Yes,
closing thoughts?
absolutely. Yeah, I want to thank everyone for showing up for this month's session and for sticking all the way 20 minutes past the session. Thank you, and really appreciate your being here. Next month's session is going to be on February 11th. We will be covering full path load linking, and that's really taking loads all the way, including all the way into the foundations that just got released today. Again, thank you very much, and that's what we're looking forward to seeing, talking to everybody next month on February 11th.
All right. Outstanding. Well, again, we thank you everybody for being here. Our team always looks forward to these sessions. It's great to have you guys. Thanks for making it a priority to drop in and attend, and we will look forward to seeing everybody next month in February. So thanks a lot. Everybody have a great one.